We're going to be talking about the important skills that you need when manipulating equipment in science practicals.
No matter what the investigation is, the steps are the same.
Now, to demonstrate these steps, we're going to be using the reaction between calcium oxide and water. This is an exothermic reaction, which means that energy is transferred to the surroundings.
And while Shinny's doing a lab scale experiment, I'm going to be ramping things up a bit on a bigger scale using this.
We already have a plan for this investigation, but before we begin, we need to identify the hazards. This is a health and safety information card for calcium oxide, and it says here that calcium oxide is corrosive. It also says that when calcium oxide is hot, it may spit. Now, to protect myself, I'm wearing this lab coat, but I'm also going to put on these goggles and these gloves.
The reaction in my experiment will be much more vigorous. So while I'm also wearing protective clothing, I also need to make sure that the space around the tank is clear and that I stand well back.
Now that we've identified the hazards, we both need to take those into consideration when selecting the appropriate equipment to use based on our plans. So for my experiment, I need to choose a beaker, and I'm going to choose this one, because it's been insulated. So when it comes to measuring the energy is not going to escape to the surroundings straight away.
Because I want to do my experiment on a much larger scale, I'm going to use this tank. And like Shinny's beaker, it's thermally insulated to prevent heat escaping to the surroundings. Now, the next thing to consider is how to best safely measure the change in temperature. And to do this, I'm going to use this infrared thermometer. It's the best option for an experiment of this scale because it allows me to take readings of temperature from a distance. It's also directional, so it allows me to see where the reaction is hottest. The downside is it only takes surface spot measurements, so it doesn't allow me to measure the average change of temperature of all the water.
I'm using this probe thermometer, which should work well because for a smaller scale experiment like this one, there should be a less vigorous reaction. So it's safe for me to measure temperature up close. This particular thermometer measures in degrees Celsius and to 1 decimal place. Now, we're both going to fill our vessels with water at room temperature, and it's important that we don't fill up all the way to the top, so we leave some space for the reaction to happen. Before we begin the experiment, I'm going to take the temperature reading, 16.6 degrees C.
And the surface temperature of my water is 16.8 degrees Celsius.
So I'm going to weigh out 5 grams of calcium oxide. That's 5 grams. I'm going to pour this into the water. Oh yeah, the temperature's definitely increased. So now the probe is reading 89.8 degrees C.
Now it's time for me to put my protective headgear on because I'm going to add 10 kilos of calcium oxide to 5 litres of water. Now remember that calcium oxide is corrosive, so I'm not going to be touching it directly. I'm going to be pouring it carefully using this metal container. That's 900 degrees.
So you can see the effect of an exothermic reaction. A lot of energy was released. And in my investigation, I was able to choose the equipment that allowed me to measure the temperature within 1 decimal point of a degree. And I was able to stir the mixture so the temperature was consistent throughout.
And we've shown that by adding more calcium oxide, you measure a bigger increase in temperature. While it wasn't safe for me to stir my mixture, thanks to my thermometer, I could take spot measurements of where the reaction was most vigorous, but not the average overall change in temperature. For me to measure that, we'd have to find some safe way of stirring the mixture.
When carrying out an experiment, you need to identify the potential hazards associated with the investigation. You should choose your equipment appropriately. And then when you're using your equipment, make sure that you're being safe and correct. And then finally, when taking measurements, choose a degree of accuracy that's appropriate. Wow, Simon, your reaction was really dramatic.
It was pretty cool to see it on a big scale, wasn't it?
It looked amazing.
Come on, you can do the big one next time. Come on.